Okay, I chose to look at holiday movie data to look at the data goes all the way back to 1900 or yeah, sometime in the 1900s. So I wanted to look at if year or genre or, target audience kind of has any impact on how many votes they get, which is through IMDb. So maybe looking at engagement or also going through and looking at rating, like average rating. So the first thing I want to look at is whether year and runtime have any potential correlation. Like as year increased, did runtime increase? Like were movies that were made earlier shorter, or are movies that are made now shorter than movies that were made at the time? So there are two data sets within this Tidy Tuesday data. One is holiday movies, and then one is holiday movie genres. Um, and they have a shared key. But then and then runtime is measured in minutes and is always a whole number. And then year is just as it sounds, also a number. Um, so the first thing I'm going to do is so first we're going to load in our data. So we have tidyverse library, ggplot library, and then bswarm library. I think I might use later. So I'm just bringing that in now. And then just reading the CSV files in using the website link to get each data set pulled. So now that we have those in, we can see them up here. When you click on movie genres, you can see like some of the keys repeat. So this movie, whatever it was listed as a drama and a romance. So this one has the repeated keys, and then also lists one genre per cell, which is kind of tidy data, but since the keys repeat, it kind of isn't tidy. So that's kind of interesting. But then holiday movies, we have one row represents one movie. We have the key, the title type, which all of these are movies. So it's not really a relevant data type. And then primary title, original title, year, runtime in minutes, again, always a whole number. Then this is the genres, which is why they've split it into holiday movie genres and holiday movies, because there are multiple within each thing. So not necessarily tidy data. And then simple title is just no punctuation, no capitals, and maybe sometimes shorter. Then average rating through IMDb, number of votes through IMDb, which I'm using to capture engagement. And then whether the title contains Christmas, Hanukkah, Kwanzaa, or a holiday, which will come into play later. So that's kind of what we're looking at for data. The first thing I want to do is capture the data into buckets of decades. So like all the movies from 2000 to 2009 would be in one decade, which would be 2010. So we're actually going to use a function to do that. I'm going to call it get decade because that's what it's going to do. So we're going to do function that takes in the year. And what it's going to do is it's going to return the floor of the year divided by 10 and then multiply that by 10. So it would take in, for example, 1978 would get the floor. This part would get 197, and then times it by 10 gives you that zero. So you'd get 1970 for the decade. So if we run that, it works. And then let's test it on get decade for, just like I said, 1978. And that should print the output, but we'll see. Yep, so we get 1970. So we're good to go. That works. So now we're going to use this decade or this get decade function in our holiday movies data set to add a variable onto the end that's called decade. So we're going to make a new data frame that actually we'll call it movie decades. And we're going to load in our function, so holiday movies. And then we're going to pipe that we're going to mutate, which just adds, in this case, it will add another variable to our data frame, and we want decade. And we're going to use that function we just created I can spell it. Get decade, and we're going to pass in the year, which is in the data set already. So then we'll run this. When we output it, we see we get a decade at the end here. So we can see 1920, 1930. As you can see, it goes pretty far back. So now let's get a summary of our data, just for a little bit of data exploration. So we have a character for the key. We have the title type, all that's characters. Okay, and then our year, our movies go from 1929 all the way until 2023. So not super current, but not that old either. And then our runtime minutes, our shortest minute is actually, our shortest movie is only 1 minute. So that's probably going to be an outlier later. And then we have maxes here, 288 minutes, which is a very long movie, so also probably a potential outlier. But then we also have this 189 missing values for runtime minutes, which is significant in our data set, which has only, let's see, it does have 2,000 entries, but I don't really like the missing data. So what we're going to do is we're going to try and fix that. But first, let's kind of visualize what we're seeing here. So we're going to create a bar chart or a box plot. No, a bar chart. Yeah. Let's do bar chart, decades. And let's look at, oops, sorry. Yeah. It already has our data because we're piping it here. So we don't need to put data as one of the arguments. And then our variable that we want to see in our bar chart is the decade. Then we're going to add a geom bar. Why is that saying that's bad? Expected end of time. Okay, I don't know what that means. And then we're going to scale. Actually, let's just output that and see what that looks like, and then see if we need to. Oh, that's what that means. Okay. So we're going to scale this potentially. Oh, no, it looks like we don't need to scale it. Well, I guess we could add a little thing here that says what decade it's in, but by process of elimination, we can get it. So this is the 20s, this is the 30s, 40s, 50s, 60s, 70s, 80s, 90s, 2000s. Oh, I guess maybe this is 90s. You know what? Let's add a scale. So let's do X continuous. This just makes it so that, this just makes it so that our x-axis, these labels are what we want. So we want one for each decade. Continuous, yep. So we're going to do breaks, then we're going to do sequence, and we're going to tell it we want it from 1920 to 2010. No, we want it to 2020, of course. And then we're going to say by 10, which will give us that decade that we want. I spell continuous on continuous. There we go. That should work. Okay. So then, yep, we can see here 2020, of course. So 2010 looks like it has the most, which makes sense. We're growing here. It also makes sense that 2020 doesn't have a ton because we haven't finished the decade of 2020, right? So we're about halfway through. So it looks like we're a little over halfway through, and it looks like that 2020 is on track to exceed. So we can see from this plot that the movie amounts released increase in each decade, which makes sense, right? Okay, so now let's try and do something with those missing numbers for our runtime minutes. So yeah, I think what I want to do is I want to put in or input those missing values with the average from each decade, right? So not the average of the whole thing, because what I'm looking for is, does runtime affect does year affect runtime minutes, right? So if we input all the missing values with just the average of the entire data set, that kind of goes against our purpose. So we want to group it. We're going to do a group by, we're going to filter um, to get those. Okay, let's just decade average data set because we want this. Actually, let's just save it to movies decade. Movie decades. We're going to save it so that, we can use it later. Decades. Okay. And then what we're going to do is we're going to filter for all the ones that are NA. So we're going to say is.na. Oh, actually, sorry. We're going to filter for all the ones that are not NA. Then we're going to do a group by. So we're going to group by decade. We're going to summarize, oops, summarize and get the average for each decade. So we want average runtime. And that's equal to, sorry, that's equal to runtime minutes, the mean of the runtime minutes for that decade. And then let's do count just so we can see, how many movies per decade. So we're going to run that, and then that's going to give us, so that each decade, oh, you know what, we didn't want to say that. So let's do average decade time. We're going to rerun this so that, we're going to rerun this. And then, because we don't want that to save to this, because we want to use this for something else. So now we're going to save it to movie decades. Movie decades. And we'll be able to input those missing values using a left join. So we're going to use left join, and we're going to do average decade time, and then by equals decade. So this is joining movie decades, left joining it with average decade time. So basically what it'll do is it'll just add that average decade time to each row or each movie so that each row has the average time for that decade that it's in. So then we're going to use mutate again, and we're going to we're going to actually create an if-else statement. So if runtime minutes is empty, or I guess NA, is NA dot runtime minutes, then we're going to fill it with the average runtime. So average decade time. And else, we're just going to leave it as runtime minutes because we don't want to change our current data. We don't want everything to be the average. We just want to update the new. So now let's run these two. Let's see what this looks like now. So, oh, we have a little bit of an error. So let's go back. Average runtime. This should not be a character. So let's try. Where did this go wrong? Because this is numeric. Yes, let's see. When we got our summary, what did we get? Let's do this. Let's do glimpse average decade time. Oh, interesting. Okay, so we need to do this. We need to do I think it's as let's see if this fixes it. Okay. Maybe when we make our decade, we need to do Let's see. This fixes it. We're gonna take this out. See if this works. Nope. Hmm. Try this one more time. Okay. Something here is not working. Let's see. Okay. I figured it out. So what we want is this is actually a data frame. So we want it to be runtime. We want it to be average runtime. That was just a little mistake of using two things very similar together. So let's run it now. Nope, not quite right. Let's see. Okay. Okay, there we go. So this looks right. So now what we can do, let's see. This should, there we go. So now what we can see is we have a runtime in minutes, and then we have average runtime on the side here. So now when we go to, let's see, let's try and find how many NAs there are in movie decades and in the column runtime minutes. And let's hope that this is zero because our if else statement, yep. So now we're good to go. Now we can actually look at the runtime plot and see if we see anything. So we're going to make a little runtime plot here. And it's going to take movie decades. And let's do ggplot. We're going to do on our x-axis, we want the year. And on our y-axis, we want the runtime minutes. So we're trying to see if year predicts runtime minutes. So we want explanatory on X and response on Y. And we're going to do, again, our geom point. Then this will produce a little scatter plot for us. So let's run this and then we'll run our runtime plot. So a little bit, I mean, mostly what we're seeing is just more movies, right? So here, not that many movies. Then as we go up, there are definitely a few outliers here that are pulling that, but you can kind of see a trend here, but you can also see a trend here. So it kind of just looks like it's fanning a little bit. Overall, not too much of a trend. Seeing some increase in time, but also, some that are definitely shorter. Mainly just an increase overall movies produced. Kind of across the spectrum there. So, yeah, basically, not really. But I wonder, yeah, I think we'll leave it there. This is pretty interesting, kind of. I mean, really, the main thing is probably this 100 sweet spot here has stayed pretty consistent. Quite a few in this little like 75-minute, a little in that 25. I wonder if those are like kids shorts. I'm not too sure what's happening here. How movies that are like 1 minute long get classified as movies, but you know. So now let's see. Okay, we see runtime minutes, not really a trend, but I wonder about maybe if certain holidays have certain engagements. So, like, as we saw in this movies, there's a bunch of data that's like, does the title contain Christmas? Does it contain Hanukkah? Does it contain Kwanzaa? Or just anything about holiday? Um, and the Tidy Tuesday thing said that like any version of Christmas, so like Xmas with a space, without a space, with a hyphen, whatever. So it tries to capture it all. So do some types of holidays increase the number of engagements, which I'm measuring by number of votes that they've received on IMDb. So to test this, um, let's look at, well, so the first thing we need to do is right now we have Christmas, Hanukkah, Kwanzaa, and holiday in four separate columns. What we want is for this to be a longer um, table. So what we want to do is we're going to create a data frame, holiday types, and we're going to assign it from holiday movies, going back. What we're going to do is we're going to pivot longer. We're going to take the columns. We want Christmas on, now I have to remember how to spell HNU. Oh man. KKH. Okay. I think I know how to spell Kwanzaa on the, let's double check. Yes, looks right. Okay, and then just general holiday. So we're gonna take those names and what we want those to be our column, or no, those are the columns we're taking. And we want the names to be holiday type. So what we're gonna do is create a data frame that looks like one column with holiday type, sorry. And then we're gonna take values to, this doesn't need to be in quotes a little, values to, and we want that to be is holiday. So we're going to see if that actually, if it is the holiday, right? And then we're going to take that and we're going to select, we want the columns, we want the key, we want the primary title, we want the genres. Actually, I don't think we want the genres actually. We want average rating, just in case we want to do some analysis with that. Number of votes for sure. And then holiday type. Oh, and is holiday. So we definitely want the two we've created. Okay, we're going to take this. Did that go? Yes. Okay. We're going to make that data frame. And then what we see is our holiday type is here and our is holiday is here. So we can group by holiday type now. And then we can do true and false. So we're going to look at distributions of these two. So we're going to do holiday type. Actually, yeah, let's do holiday type. And then we're going to call it for distributions. We're going to take in our newly created holiday types. We're going to type that and we're going to do ggplot. And our axes are going to be X is going to be is holiday, so true or false. And then, oops, our Y is going to be number of votes. So to look at engagement, right? Then let's do a box plot just to kind of look at that distribution. And then we're going to facet wrap it by holiday type so that each holiday gets its own plot, one with yes or one with true and one with false. So let's look at that. Okay, so a ton of outliers that we can't really see anything that's going on. A lot of outliers in the false. Not too many in the trues. Okay, so let's fix this. So we're gonna, so based on these really big numbers here, I think it would be best to maybe scale this data. So we're going to use the logarithmic scaling to, we're going to create a new data frame. We're going to call it logs, because this is going to take the log of the holiday types. Yep. Okay. We're going to take the logs. We're going to use mutate again, and we're going to do log votes. We're going to take the log of each number of votes so that we scale it down, but keep the data. So then let's create our box plot that now takes in our holiday, this logs data frame. And now we create another plot, but this time our X is holiday still, and our Y is going to be log votes so that we, can see some more of what's going on. We're going to do geom box plot again, and then we're going to facet wrap by holiday once again. So, and we're going to do holiday type. Okay, let's see if we can get some more information here. Okay, yes, here we go. So now we can look at this and we can see, what do we see? So Kwanzaa doesn't have too many movies in its type. But let's see, Christmas has more votes when Christmas exists in the title than when it doesn't. The rest of them are the opposite. So potentially, so Christmas has more votes, or let's say Christmas, the average number of votes for Christmas is higher, right? For Christmas, for when Christmas exists in the title is higher than when it doesn't exist. For all the other holiday types, including general holiday, this is not the case. So potentially, Christmas gets more engagement. But as we can see, the means aren't too terribly different. I mean, this is between 3 and 2. So, pretty similar overall. Not really too much of a trend there. So now let's see about movies and genres. See about whether, certain genres get higher ratings than others. Because what I'm really curious about with this data is, does family-friendly or Christmas-related get more than like Hanukkah or holiday or Kwanzaa, which as we saw with this, kind of, maybe. But does the American like focus on Christmas translate a little bit? And then within that, does the rating increase for certain genres? So maybe, my initial question is, does family-friendly genres get higher ratings? And maybe my question should have been, do family-friendly genres get more engagement and looking at number of votes? But let's test this rating within each genre. So this time we're going to need that holiday genres, right? We have that already. It makes the data cleaning for this very easy, because if we were just using holiday movies, we would have to split and create a bunch of new columns, and we don't want to do that. So we're going to use our holiday movie genres, and we're going to do some joining with it. So we're going to do movies join. We're going to create a data frame. This will have a row for each genre, not necessarily a row for each movie. So within each, as we saw in this, each genre could be repeated potentially. So we're going to take in our holiday movies, our initial data frame, and we're going to do a let's join. Oops. Or actually, first, we're just going to select the columns we want. So we want We definitely want the key. We want the title, maybe. We want the year, probably. We want runtime minutes, just in case. And then we definitely want average rating. Let's bring in num votes because, that's another indicator here. So now that we have this, we're going to use it to do a full genre data frame. We're going to use left join, and we're going to grab the movies join column that we just created. And then we're going to take holiday movies, movie genres. Yeah, movie genres. And then what we're going to say is we're going to say by, and we're going to indicate left join should recognize that this is our primary key or key, but just in case, we're going to make sure it does. So, oh, spelling mistake, movies. Now we can see that we have one row for each genre. So that's what we want. Let's see. So Devil's Holiday is repeated. This is good because that means we do have one row for each genre. So that's perfect. That's just what we wanted. And also our genres have ratings that go along with them. So that is perfect. That's just what we wanted. So now let's look at the distribution for the genres. So we're going to do a ggplot. We're going to probably this is where we're going to bring in the B swarm. Just because I like seeing the concentration of where they are. So let's do, our data is going to be full genre. Our axes are going to be, X is going to be genres, and then Y is going to be average rating. And then we're going to add that to the geom. We're going to do B swarm plot, like I said. So let's see what this looks like. Okay. We can't really see much of what's going on. Obviously, some genres have significantly more entries than others, which, like here, we wouldn't expect Western to have a lot of entries, right? We wouldn't expect war to have a lot of entries. Romance, probably. It looks like it's taking up a lot. We would expect that. But let's try and clean up, maybe. Let's try and remove some of these genres. Some of the ones like Western that don't have a lot of entries. So let's create a new data cleaning data frame. Actually, first let's take a look. What even are the genres that we have? Let's see full genre, and let's look at genres. What genres do we have? Okay, so we have 27, 26. Oh, we have an NA, so some aren't filled in. Film noir, I'm guessing, doesn't have a lot. History might have some. News, talk show, yeah. Short. We probably don't want some of these. So let's go ahead and do some data cleaning. Let's get rid of some. So let's create a cutoff distribution. So we'll do a little group by. Let's do a cutoff. We'll take in our full genre data frame. We're going to filter. We're not going to include the is NA genres thing. Because if it doesn't have a genre affiliated, it's not important to us, right? We don't need to fill that. Then we're going to group by all of our genres. And then let's do a summarize. And let's do count equals just the count of how many there are. And then let's filter. So we want, let's say count has to be, I don't know. Let's start with 20. See what that gets us. Okay. So now we're going to take this information. We're going to say our genres included are going to be from our full genre. So this will give us, what this gives us is a list of, here, let's just run it so we can see. This gives us a list of genres that fit our cutoff. So, and it's summarized. So looks like we have 16, so that's pretty good. Action has 31, adventure has 117. So what we're going to do is we're going to take this information and we're going to create a new data frame that talks about our genres included. And we're going to say if genre is in, we're going to filter for genres that are in the unique genres count cutoff genres column. So if the genre is action, adventure, animation, comedy, etc., it will be included. And if not, it will get dropped off. So let's see. Let's first do, okay, 4,440. Let's see, how many did full genre have? Okay, so that didn't really drop off a ton, but let's see if it made our plot a little better. So let's look at, let's do a new genre distribution plot. Hopefully it's slimmer. So we want ggplot, our data to be genres included. Our axes are going to be, our X is actually going to be blank for this. You'll see why in a second. We want our Y to be average rating. And then we're going to add that and we're going to do geom B swarm, of course, because that's our main plot type that we're using here. Then we're actually going to facet wrap it by genre so we can kind of see a breakdown better. So let's look at this. Oh, layer 1 is missing. Oh, it needs to be plural. Okay, so let's look. Okay, so this is looking better. We can kind of see what's happening here. Still a little crowded. I wonder if we let's increase this to 40. See how that looks. That's slightly annoying that there's one too many. Let's see if 45 does the trick. If not, we'll adjust. Okay, perfect. So for those that have 45 entries or more in our data set, we can see this. So this kind of gives us some information, not a ton, um, but a little bit. It looks like music is actually pretty high. Um, Romance is kind of up there. Drama looks like it's up there. So let's see if we can arrange these plots to actually give us something that we can use. So we'll just do it in here. We're going to do what's called reordering so that we can actually order these by their means to see which one actually comes out on top. So we're going to keep using our genres included because we don't want to use genres that we don't want to look at. We're going to pipe that and we're going to group by genre again. Then we're going to mutate. So what we're going to do is we're going to do mean rating, very similar to what we've done earlier. So we're going to take the average rating for each genre type. Then we're going to remove the NAs, like I said earlier, because if it doesn't have a rating, then it's not very useful to us. And then we're going to ungroup these, and then we're going to mutate, and we're going to reorder the genres to be ordered by mean rating. So that will kind of and actually we want highest at the top. So we're actually going to want decreasing equals true here. So let's do this. And let's see what we get. So now we're going to need to make that plot again. So we're just going to copy and paste our information from up here. We don't need to do it again. We're going to run all this, and then let's look at our distribution plot. So interesting. So documentary is top, which kind of makes sense based on what we can see here. But it kind of looks like, wow, horror does not do well. It kind of looks like to me that those with fewer movies kind of do better. So maybe let's look at only those who have above like 200 and see. Because what we really want to know, like documentary, music, short, musical, I guess adventure, horror, not really fantasy. I guess fantasy is pretty common, but not really holiday movie types that I think of. I think of more drama, family, romance, comedy, animation. That's kind of what I think of more. So let's try and do this again and look at only those with a lot of rankings. Okay, so this is kind of making sense. So what we see here is actually comedy doesn't do well, which isn't too surprising. Animation, again, doesn't have that many plot points and it kind of seems to be driving it. Um, but yeah. So in a sense, I was kind of right. I feel like comedy's taken the least seriously, which could potentially correlate to why their ratings are lower. Let's bring this out a little bit. See if we can see anything with this a little bit bigger. Yeah, so it looks like those comedy looks to be one of the ones with more ratings. Romance does better than comedy, which is kind of surprising to me, just because I feel like there's a ton of like when I think of holiday movies, I think of Hallmark movies, which in my mind don't get that good of reviews or ratings. They're kind of cheesy. But yeah, so what we see here is the animation emerges victorious in the ratings in the average rating for genres of holiday movies. Comedy performs the worst of the most ranked movies with romance just. And actually what we can do here is we can look and see, let's look at this average rating, mean rating. So comedy, I mean, none of them are high. Let's do before we ungroup. Let's do this. Oh, that didn't work. Well, that's okay. Oh, wait, I included the ungroup. Of course, that wouldn't work. Oh, that didn't work either. Oh, well. Um, but yeah, so none of them are terribly high, but we get in the sixes. I would say probably holiday movies aren't the best place to look for where we have high ratings. But yeah, so overall, what we kind of saw is that runtime and year not super correlated with each other. It doesn't seem to be. What does seem to be the case is that more movies get released as we get higher into the years, right? Which we saw with this decade bar. And like I said, this will probably overtake that 2010s bar. And then with this box plot, we saw that movies that have Christmas have more votes than movies that don't have Christmas. And the rest of them, um, the trend is the opposite, but probably not too significantly. Like I said, these are both within the 2 to 3 range. And then with this one, oh, I got rid of it. With this one, we saw animation takes the cake, highest rating. Drama's up there, which is interesting, but I feel like kind of makes sense because it's one of those that again is taken more seriously, whereas romance and comedy are not as critically acclaimed, I guess. But yeah, animation being up here and family being up here does kind of make sense with what I was thinking. So in the future, something you could do that could be interesting would be number of votes. Sorry. Yeah, number of votes per genre and seeing like, does animation get more engagement than drama or than war? So yeah, that's what I have. I hope you enjoyed and yeah, I hope you learned a little something. Thank you.